Welcome back. We are back on our technical presentations after the opening panel discussion. Now, we are going to have a few presentations coming in, and we're going to be talking about developing the methanol and the hydrogen economy with gasification. Now, energy transition using low carbon technologies is happening at an unprecedented pace and scale as the world battles global warming. While renewable energy is gaining momentum in India, blending clean fuels with diesel for transportation and LPG for cooking can help reduce emissions. We have an ethanol blending program, and now that coal has been commercialized, methanol derived from coal can also be used as a cleaner fuel and can be added to diesel. And hydrogen fuel cells are already powering buses and cars in many parts of the world with zero emissions. Currently, most hydrogen is produced from fossil fuels, largely natural gas. But when we don't produce our own gas and depend on imports for it, can coal prove to be a viable alternative? To discuss this topic of developing the methanol and hydrogen economy with gasification, please welcome our esteemed speakers. We have Mark Clune, Director of Business Development, Air Products, and Dahl. He's fellow at Haldor Topsoe. We will also be joined by Dr. Prakash D. Chavan, Senior Principal Scientist and Head of Research Group, CIMFR. We'll also have Dr. R.K. Malhotra, President of Hydrogen Association of India, who will be giving us the presentation. We have Mark and Mr. Dahl with us, so I would request them to kickstart this discussion, and please give us your presentation.
Anisha, good morning. Thank you very much, and thank you for giving us the opportunity to talk today. So, my name is Mark Clune from Air Products, and this is a joint presentation with my colleague Per Juul from Haldor Topsoe. Together we're going to give you a presentation and talk about coal to methanol and some of the exciting developments Air Products and Haldor Topsoe are delivering in this area. So if we go on to the next slide, please. So, first of all, I'm going to give you a brief overview of an exciting development in our eyes this year. That's a formal alliance between Air Products and Haldor Topsoe. So I will go on to talk through the build, own and operate business model that we offer under this alliance very briefly. More details of that can be heard in other sessions later today. And then I'm going to hand over to my colleague Per, who will talk through details of the methanol processing step. So firstly, I think you're very familiar with both the names of Air Products and Haldor Topsoe. So we're both leaders in our own areas. So Air Products a significant producer of hydrogen worldwide. We own and operate some of the world's largest industrial gas facilities and are the largest producer of hydrogen and syngas in the world. So we are experts in developing projects, executing them, and operating the resulting plants. Haldor Topsoe, I'm sure you're all familiar with the world leader in many different technologies, but especially in products such as methanol, ammonia, and other chemicals. They're the world's largest licenser of many of these production technologies. And experts in catalysts and other solutions for this. Together, we have come together, and earlier this year, we announced a global alliance where Air Products and Haldor Topsoe will work together to deliver various methanol, ammonia, DME projects. It's a single-stop shop where customers can go to and result in a world-class designed integrated facility, taking the coal and delivering the finished product to the customer. So with what we believe is unmatched efficiency, safety, and reliability. So all in a low-cost business model. If we briefly look at this process diagram, Everything on here can be delivered to customers through coming to the Air Products Haldor Topsoe alliance. It's a single point of contact that you will have. Air Products will build, finance, own, and operate everything you see on this screen. So giving customers an unrivaled opportunity to supply coal and take the resulting product, be it methanol, DME, or ammonia, to use in their downstream processes or market further on. You will have seen Air Products in earlier sessions talk about our unrivaled position in the gasification technology space. We offer this under what we call a build, own and operate business model, where we will take responsibility for the full financing of the project, full responsibility for the design and construction of the project, and we will then take full responsibility over 25-year contract life for the efficient production of the end products. This gives customers many different benefits, which I won't go into here now, but my colleagues in a later session today will happily go into these details. We go on to the next slide. Finally, from Air Products, this is all a great story. It's easy to see on slides. We're actually executing this today. Earlier this year, we announced one of the world's largest methanol plants to be built. It's being built in Indonesia under exactly this business model. 100% financed by Air Products, using Air Products gasification technology and Haldor Topsoe's methanol production technology to take 6 million tons per year of coal and produce 2 million tons per year of methanol for our customer. It's $2 billion capital investment, all being financed by Air Products, and we expect it to be on stream in 2024. Now, if I hand over to my colleague, Per, he will take you through the Haldor Topsoe technology behind a lot of these opportunities.
Thank you, Mark, and welcome to my presentation on methanol production based on coal gasification. The picture you see here on the screen is our autoturbine reformer used for Topsoe's natural gas-based CIMFR technology. Why show it here? Because the synthesis gas generated from CIMFR has similar strength as synthesis gas from coal gasification. Actually, Topsoe gained a lot of useful experience designing methanol projects for coal gasification, an experience which today is used in our CIMFR technology. What is methanol from coal? If you remember the slide Mark showed earlier, the methanol synthesis is only a small section of a coal gasification plant where the resulting product is methanol. Nevertheless, it is an important section in terms of overall efficiency and reliability. The picture shows a methanol reactor section where 3 so-called boiling water reactors are operating in parallel as one reactor with a common steam drum on top. Topsoe has today plants in operation with up to 4 reactors in parallel, but there is no limit to the number. For a specific project, the number of reactors depends on the capacity and transport restriction. Let us look at the full methanol synthesis section. I hope you can see my pointer. The makeup gas from the upstream coal gasification section is entering at this point. The makeup gas contains hydrogen, carbon monoxide, and a small amount of carbon dioxide and is slightly under stoichiometrics in terms of hydrogen. The upstream units adjust this composition by adjusting the amount of shift from carbon monoxide to hydrogen and by removing carbon dioxide before going into the synthesis. The gas is compressed, preheated, residual sulfur is removed in the SCART reactor and then added to the recycle stream before entering the methanol reactor. The gas passes actually through the boiling water reactor in tubes filled with catalyst, which convert part of the gas to methanol close to equilibrium for reaction. The conversion is heavily exothermic. The reactor tubes are therefore surrounded by boiling water, removing the generated heat as steam. The reactor exit gas is cooled by preheating the feed gas, the recycled gas, and in a final cooler, where the main part of the methanol is condensed out as liquid so that it can be separated from the residual gas, which is recycled to the reactor. Part of the gas is, however, purged to avoid build-up of inerts. Any leftover methanol is washed out of the stream and sent to a hydrogen recovery unit. The recovered hydrogen is then recycled back to the make upstream so that we end up having a stoichiometric gas entering into the synthesis loop. The off gas is used as fuel. The product crude methanol is further depressurized and sent to an intermediate storage. What is the major advantages of this layout? The key component is the boiling water reactor. Synthesis gas from coal gasification is an extremely active gas for methanol production. Unfortunately, such an active gas also produces more byproducts if the temperature is not well controlled in the entire reactor. Topsoe's axial flow reactor ensures best possible temperature control by simple pressure control of the boiling water surrounding the catalyst bed. The design ensures best possible utilization of the catalyst. There is no uncooled catalyst pocket and all catalysts see the full flow. In terms of energy consumption, the solution ensures maximum recovery of the reaction energy in form of steam, and the efficient temperature control and increased catalyst utilization reduces the required recirculation rate and thereby the loss of energy in the final cooler and recirculation compressor. The very easy and safe temperature control provides a very efficient byproduct control, both when the catalyst is new and very active and later when it has deactivated. The efficient temperature control also enables use of highly active catalyst. Speaking of which, Topsoe has the superior methanol catalyst on the market. Topsoe's MK151 methanol catalyst using fence technology is superior. We have not stopped our development, and a new and even better catalyst is on its way to the market. Thus, you can say improve performance in the future. The fence technology inhibits sintering, mainly maintaining activity for longer time. The technology keeps the active copper crystal small, providing high activity with low byproduct formation. The methanol synthesis produces a methanol stream which typically will need to be refined. This takes place in the methanol distillation section. The picture shows a typical world-scale distillation producing grade AA methanol. A simplified flow sheet for the section can look like this. Common for most design is that the methanol containing stream from the synthesis is stored in an intermediate tank before further refining. This is done to ensure a stable operation. The first column, which we name stabilizer, is also common for most systems. It mainly removes light gases but can also be used for adjustment of water content and byproduct. The design of the remaining part of the distillation section depends on capacity, energy consumption, and quality requirement. What is shown here is a large-scale grade AA distillation. Topsoe has an excellent reference list on providing technology for methanol production based on coal gasification. Xianyang methanol plant in China is one example. It was started in 2010. It has a nameplate capacity of 2,000 metric ton per day using a single boiling water reactor. The capacity is now 108%. Topsoe supplied basic engineering, detailed design and high pressure equipment, proprietary boiling water reactor, and catalyst. Our reference list for our coal-based plant look like this. It contains 11 projects which has been started since 2010. Okay, so much for the methanol section. Topsoe can also provide technology for other sections in the coal gasification complex. For example, the required shift section used to adjust the feed composition to the methanol synthesis loop. Topsoe can provide both a sour shift solution fed with sulfur-containing gas or alternatively a shift section based on sweet gas where sulfur has been removed ahead. In any of the cases, we can provide basic engineering and catalyst. We can also help to reduce the sulfur emission. Coal typically has a high content of sulfur which has to be removed from the gas prior to methanol synthesis and prior to any other uses of gas from coal gasification. The section removing the CO2 is typically also removing the sulfur in an off-gas stream. The sulfur in this off-gas stream can be converted into solid sulfur in a Klaus plant, or as shown here, into sulfuric acid in a Topsoe VSA plant. It's not always that sulfuric acid is a requested product, but if that is the case, Topsoe can also improve the Klaus plant operation, as shown here. As shown here, the combination of Klaus and Topsoe's VSA improves the sulfur recovery from 97% to 99.97%. This ends my presentation today. So thank you for listening to me and Mark. And if you have any questions, we are ready to answer.
Many thanks for that presentation, Mark and Mr. Dahl. What we'll do, we will take up the questions that are coming in, but we have another presentation coming in from Dr. Prakash Chavan. We will do the presentation first and then go to the questions. So I request your patience, please. Dr. Prakash, are you ready with your presentation?
Yes, madam. Yeah.
Right. Could you please start with your presentation then?
So, very good morning to all of you. I am presenting the program which is being pursued at CIMFR, Dhanbad, related to coal gasification as well as methanol generation. I think in morning session as well as yesterday session, several speakers has already highlighted the importance of Indian coal as well as the importance of gasification and challenges in connection with in Indian high ash coal. So I will not give much time in that part. Directly we can go to the strategy being targeted in the India in view of Indian coal's properties of Indian coal and challenges in Indian coal gasification. So first of all, proper understanding of the Indian coal is essential in view of its physicochemical properties and mainly ash properties in order to proper selection or development of the suitable gasifier, as well as how should be the utilization strategy and pattern for its proper utilization. Then another program which is chalked out by Nitayok is development of indigenous technologies. So as a part of that program, already in first phase, pilot scale gasifier development suitable for Indian coal is being pursued. And third program is related to comparison of commercially available technologies, various technologies, and indigenously developed technologies, and economic comparison of the all these technologies in view of Indian coals. So this is the overall program, we can say. This is divided in two parts. Already Niti Aayog has interested activities, mainly installation of commercial gasifier, mainly we can say entrant flow gasifier, suitable for low ash coal, as well as high ash coal after washing and blending. So few plants, commercial scale plants, will be installed at different mine mouth locations, and this particular program will give feedback related to performance of the commercial technologies in view of Indian coals. Parallelly, indigenous gasifier development program is also there. So in first phase, 4 organizations, including CIMFR, we are installing pilot scale facilities. Already we have installed, and it will be integrated with the syngas utilization for methanol at the downstream. And then input from this particular phase will be utilized for demo scale development as well as commercial plant development. So finally outcome will be indigenous technology development for gasification as well as methanol generation. In this direction, already our institute, CSR CIMFR, has initiated a very big program, multifaceted program in this direction. And first important activity is understanding Indian coals towards gasification, so that we can get correct idea about the suitability of gasifier as well as utilization pattern. And then development of Indian fluidized bed gasifier suitable for high ash Indian coals. And third activity is related to installation and integration of the around 250 kg per day syngas to methanol pilot plant with newly developed fluidized bed gasifier plant. So I will discuss these 3 activities in short. Apart from this, in this particular direction, we have established Center of Excellence for Coal Gasification and allied activities, well equipped with various pilot plants and state-of-the-art analytical facilities towards gasification, as well as modeling related laboratory and even training and skill development center also. So while coming to first activity, that is understanding of Indian coal, already we have completed this particular program, that is gasification potential mapping of 3 subsidiaries of Coal India, MCL, CCL and ECL. Around 36 mines we have covered under this program, and we have developed characterization matrix consisting of several physico-chemical properties as shown in this particular slide. And from this particular characterization matrix, we have developed utilization pattern as well as criteria for selection of the suitable gasifier. And we have also suggested the utilization options, or we can say blending and washing patterns necessary for utilization through different type of gasifiers. And this particular report we have submitted to Niti Aayog for further steps to take in view of Indian coals. And from this particular study, we can say that these 4 important parameters or properties are very much important in view of Indian coals, mainly ash content and ash properties, including ash fusion temperature or ash composition. because we are aware that Indian coals are having high ash content as well as high ash fusion temperature also. Fortunately, Indian coals have good reactivity as well as mechanical strength, so which is essential for few type of gasifiers. And based upon this particular study, we have suggested criteria for selection of gasifier for Indian coals based upon ash content as well as ash properties, which are essential for mainly entrant flow gasifiers. And for when we think about moving bed gasifier, mainly mechanical strength and reactivity, these properties are necessary. Again, depending upon ash content, blending and washing steps also we have suggested. But for fluidized bed gasifier, we can say which is suitable to handle high ash coals also. So we need to think about reactivity and mainly agglomeration related aspects, ash fusion temperature and ash composition. So in detail, strategy for selection as well as for utilization pattern we have suggested under this particular report. And we have chalked out three options. Suppose for particular mine, we can go for any type of gasifier, but suppose if we go for entrant flow gasifier with high ash coal, definitely washing or blending will be necessary to bring down ash content within acceptable limit. And certain issues related to capex opex we need to consider when we go for entrant flow gasifier. Again, in view of Indian coals, since ash fusion temperature is on higher side, so definitely we need to concentrate on mainly membrane based technologies like shale or similar type of technology, because definitely higher gasifier temperature will be necessary to achieve desired viscosities. So definitely high temperature entrant flow gasifiers we need to consider here. Again, suppose when we consider moving bed gasifier, in that case also we need washing or blending to some extent. But under this particular technology, one issue is related to selective feed particle size as well as tar generation and liquid product generation. So it will definitely it will attract capex for washing as well as for tar and liquid product handling. When we think about fluidized bed gasifier, definitely it can handle high ash coals directly, but proven technology is not available under this particular category. We are aware. Another aspect issue is related to fluidized bed is lower carbon conversion. So in this particular aspect, we have initiated the program development of suitable fluidized bed gasifier for high ash Indian coals long back, and in 2009 we have installed this particular fluidized bed gasification facility. And after testing various coals from different coal fields of India in this particular facility for 10 years, even coals as well as their blends with biomass, and achieving success in this particular facility for and development of the operational philosophy to handle high ash coals. Now we have already upscaled this particular facility to 1.5 tons per day coal handling, and recently on 17th of November this facility has been inaugurated by Honorable Minister Science and Technology, and now we have conducted trial run in this particular facility, and now we have achieved syngas composition, mainly CO and hydrogen in the range of 12%. This was just a trial run. in air-blown mode. Now, next target is to establish the operation in oxy-blown mode with high-ash Indian coals and develop operational philosophy to handle the high-ash Indian coals, and subsequently understand the gasification prospects as well as generate techno-economic data which is necessary for demo scale and commercial scale plant development program of the Niti Aayog. And simultaneously, we are in the process of installation of the 250 kg per day syngas to methanol pilot plant and its integration with this newly developed 1.5 TPD fluidized bed facility, as well as to strengthen our developed center of excellence for gasification in all respect necessary for gasification and syngas utilization. So we are already in the process of development of syngas microcleaning and conditioning. This will be completely in-house developed process for cleaning and conditioning of the syngas as well as syngas to methanol conversion. It will be integrated with the newly developed PFBG facility, and it will give a complete solution for coal to syngas as well as syngas utilization for methanol. And at the outset, we can say this particular program is development of indigenous fluidized bed gasification pilot plant. Is a milestone achievement towards methanol economy program of Niti Aayog as well as Atmanirbhar Bharat Abhiyan of the Government of India. And from this particular development, we can get idea about gasification potential and techno-economics related to Indian coal gasification, as well as their utilization prospects towards various downstream applications like chemicals or methanol generation, fertilizers, and other applications. And development from this particular program will be utilized for demo scale program of the Niti Aayog. So this is the overall about our in-house program of CSIR CIMFR. Thank you, madam.
Thank you, Dr. Chavan, for your presentation. Of course, there is a lot of promise in these new technologies, and there has been debate on how we can best utilize these and what will be most suitable in India's condition, given the kind of coal we have and given the fact that we really haven't had a lot of underground coal mining in our country so far. Dr. Chavan, I request you to stop your screen sharing.
Yeah.
Yes. Thank you so much, sir. So we have a couple of questions that are coming up. So I'm going to hand over the mic to Mr. Bhaskar Bhattacharya, his Chief Manager, Eastern Coalfield, Asansol. Mr. Bhattacharya, please go ahead and ask your question. Keep it short and tell us who you're asking the question to.
Good morning, ma'am. Good morning, dignitaries. Myself, Bhaskar Bhattacharya from Coal India Limited. I'm extremely obliged to get this opportunity to place my question in this forum. Actually, Coal India is in the fray of surface coal gasification from coal to methanol and coal to other downstream products. So, from my first question is that M15 blending plan of the government, I want to know about that. Is there any clue on that? And my second question is that how coal gasification be beneficial when we have imported methanol at a very low cost, particularly methanol which we import from the Gulf country where they prepared methanol from cheaper gas. These are the questions. Thank you.
It's your first question for Dr. Chavan?
Yes, madam. Basically, when we see the gasification and syngas to methanol process, gasification is just a simple process to convert coal into syngas. So when we talk about cost calculation, major part goes to coal, and whatever processing cost is there, yeah, definitely by improving efficiency and conversion, we can minimize those costs. But definitely we need to consider coal cost, and it will drive the final methanol cost. So we need to concentrate on the coal cost first. Another aspect is when we talk about single product generation, say methanol or fertilizer or power, definitely cost will be on higher side. But when we go for poly generation, consisting of simultaneous generation of say fertilizer, where we can utilize separated nitrogen from the oxygen generation plant, as well as CO2 separated during water gas shift reaction. So when we utilize all these streams, nitrogen, carbon dioxide, and all the waste heat streams, and utilize for ammonia and subsequently urea generation, then there will be quite value added utilization of all the streams, and it will bring down the overall cost of fertilizer as well as power generation or other stream also. So poly generation, I think it is a attractive option to bring down the overall cost of products or well-loaded product generation using coal gasification.
Mark, would you like to take the second question? He said that, would methanol from coal make sense when methanol from gas is so much cheaper and India is importing it? Now, this is a question not specific to India alone, because methanol is produced by hydrocarbons, mainly gas, and gas prices have fluctuated in the past, but for now, they are low. So anything you'd like to add here?
I can't go into a lot of details on that as we're more in the middle processing. But what we do see from the market is many customers around the world do believe that it can be a cost-effective solution. I think each individual opportunity needs to look at its own merits. So what is the input cost of the coal going into the plant? That's a big consideration, and we see different people having very different views on the input cost of coal. And then people also need to look at what their own local drivers are. Is it security of supply for 15, 20 years that they're after? So are they worried about the long-term supply chain? Are they using the product themselves? So there's a number of different factors. I think ultimately, if you look around the world, there are people making significant investments, not just in China, but in other countries, taking coal and converting it to various downstream chemicals. Those people, I think, are showing that there are certainly numerous scenarios where the economics do make sense.
All right. Thank you for that answer. We have Mr. Avdesh Tiwari of JSPL who is here to ask a question. Avdesh, would request you to unmute yourself and go ahead and ask your question.
Yeah, today the worldwide methanol capacity utilization is less than 80%. And as Mr. Bhaskar told, the methanol prices fluctuates almost from $120 to $400 in a year. So how viable it is with the coal in India? And India is not consuming much of the methanol also. Even words 50% methanol is produced by China, and other 50% which is produced by other countries is consumed by China itself. So what will be the viability of this project, and what will be the end use of the methanol in India? Is there any plan and something like that?
Your question is for Dr. Chavan.
I think Chavan can also answer, and Mr. Mark and other, because they are producing methanol with the coal in other countries. So they will be able to give what will be the production cost of the methanol at least. So we know from the coal what is the cost of the production. Then we can know the viability.
Dr. Chavan, similar to the previous question, could you answer?
Yeah. So I think it is already answered in the earlier question. So mainly it is when we talk about the cost of the generation of methanol, cost of coal is important factor because it contributes a lot when we compare the production cost, processing cost, and raw material cost. Another aspect, definitely we need to consider about poly generation, as already I have mentioned during discussion. Because when we utilize all the streams, mainly generated nitrogen during oxygen separation plant, as well as carbon dioxide, which is generated in the water gas shift reaction. When we utilize properly all these waste streams for generation of fertilizer, ammonia and fertilizer, so in totality, it will bring down the overall cost, and definitely it will give benefit to bring down the cost of the methanol as well as other products also. So poly generation and cost of the coal, these two factors are important to bring down the cost of the methanol.
Right. Mr. Dahl, would you like to talk to us about what methanol could be used for in India? The person asking the question mentioned that a large part of it is made in China, and China uses it, nearly all of it. So China must find some useful application, right? Can we learn something from them? We have a lot of coal, so if we turn to methanol, where could we use it?
Yeah, it's not within my line of business, but my impression is that you need to see increased methanol production as you can say a replacement of existing transportation fuel, for example. What we have seen in China is that they are using you can say a lot of the methanol they produce for MTO and such things, but also for transportation fuel. Similar things are happening in Europe, where part of, you can say, there's a big discussion, what should our naval fleet use for fuel now that they are not allowed to use bunker fuel anymore. Part of this bunker fuel has to be replaced with something else, and replacing that with methanol will require a huge amount of methanol production. So, but there are various players into this. So what will win? Maybe it will be a combination of everything. So for sure, methanol is a very easy molecule to use for these things. It's an excellent energy transporter, etc. So, and it's an excellent way to replace other fuels in your total fuel pool. So that's my opinion on this.
All right. Thank you so much, Mr. Dahl. We have a question from Narendra Agnihotri of HPCL Mithun Energy. Narendra, go ahead and ask your question.
Yeah. I have a question for Dr. Prakash. My question is that what is the carbon to hydrogen to carbon monoxide ratio in your process? What is the you are making the methanol? And second, have you checked with the pet coke in this to replace the feed from coal to pet coke? Or second thing, because methanol blending is going on, a lot of talking is going on to blend the methanol with the gasoline or liquid, but methanol is highly corrosive. So the people are thinking about the ether because it has a high value product also. So what do you think about it? We have to go methanol or we have to go dimethyl ether for this product?
Mainly when we go for bubbling fluidized bed, definitely hydrogen to CO ratio will be 1:1. And as per requirement of syngas to methanol process, we can modify the ratio by water gas shift reaction. There is no any issue at all. When we talk about second, what was second question?
I think the question was about the corrosiveness and whether the other...
No, another question was there.
The ethyl, which is less corrosive, should that be utilized as opposed to methanol? I think that was the question.
I'm not getting exactly the question. Apart from hydrogen CO ratio, some another question was there.
The question was that methanol is very corrosive. You can also, I think, use other derivatives like ethanol, not ethanol.
I think
So
it is
would those be
related
better?
to application related question. Mainly people from other sector, that is utilization for IC engine, they are working in this area. That is not my area actually. So they are developing the suitable engines and components required for methanol, keeping in view this particular aspect, corrosiveness. So we can get idea from other institutes. IIT Kanpur is working in this particular area.
Okay, I think the question.
Yeah, petcoke related question was there, and we have not tried petcoke because petcoke reactivity is very poor. So handling in fluidized bed, it will be very difficult. But definitely, when we go for catalytic petcoke gasification, because fluidized bed gasifier have limitations related to temperature. So conversion within 1050 degrees Celsius, maximum 1100 degrees Celsius we can go, and the proper conversion we need to get at that.
Okay, we have one more question coming in from Manish Meena, and I will ask him. Yes, Manish, go ahead and ask your question.
My question is for air product members. I want to ask, they have presented that in methanol process, there is generation of HP steam and low pressure steam. So how can we use HP and low pressure steam in methanol plant efficiently? Because there is much more energy in the HP steam and low pressure steam, and at very high temperature it will be generated.
Thank you very much, Manish, for your question. I'm not a technologist, and so would have to ask some of my colleagues for a more detailed answer of that. But with every opportunity we look at, it's important to make sure you get the integration of all the different set of utilities and processes together. And you can use different technologies in the gasification stage, to generate different levels of steam, and then depending on what you require, downstream, perhaps in your shift stage, where you may be using steam. And then surplus steam can often be utilized by our customers, where they have other processes taking place on the site. So it's important to look at the overall opportunity and pick the appropriate technology for exactly what you're trying to achieve. Air Products is very well placed with the broad range of different technologies in the gasification field that we have in order to help people work through that in detail.
Mark, we have the question from Mr. Venkatram. He's typed it out. His question is to you, and he's asking, are you using lignite in Indonesia? And if so, how are you drying it?
So thank you very much for that question. I'm not going to go into details of exactly what we're doing in Indonesia. So there's certain levels of confidentiality around that. So, however, there are customers of our gasification technology who do use lignite as the feedstock. I'm not aware of the details as to how it's processed before it goes into the gasification, or what type of gasifications we typically use. My colleagues would be able to answer that. That more technical question. So, if there's an interest in that.
Right. We have another question, and we'll ask Mr. Avdesh Tiwari. He's asked a question before, but we'll ask him if you can hear me to go ahead and ask a question. Mr. Tiwari, go ahead and ask a question.
Yeah. No, sorry, I was not asking the question that he was asking regarding the steam utilization. Normally in methanol plant, the synthesis gas compressor is driven by that steam. Whatever will be produced in that synthesis, that is for driving the compressors, and it can be utilized in the shift converter also. So steam utilization is not a problem in the methanol plant.
All right. I think that about. So we have one more question from Mohammed Shah Nawaz. He's Deputy Manager Coal Preparation. He's joining us from Ranchi, I think. Mr. Shah Nawaz, please go ahead and ask your question.
Okay, ma'am. I am going to ask Mr. Mark Clune. What is the cost of production from high ash coal of about 34% to 36% ash to SNG apart from cost of coal? Thank you for giving me the opportunity.
Thank you very much for your question. As I'm sure you can imagine, there's a significant number of factors go into that. Gasification is a capital-intensive process, and the capital component will be the largest single factor of that. But without understanding a lot of other factors, it's impossible to just give a number off the back.
All right. Mark, there is one question which is coming from Prasanna, Senior Manager at Praj Industries. So his question is, how do you compare Indian coal gasification versus biomass gasification technically and economically for methanol and hydrogen production in India?
Yeah.
Dr. Chavan, I request Mr. Mark Clune to answer that. We'll come to you on that as well.
Yes, please. Please.
Yes,
go ahead. Thank you, Anish, for the question. I'm not familiar with specific comparisons, specific evaluations done between municipal waste, biomass in India versus coal gasification. So it is looked at in different geographies. There's significant other challenges with taking biomass and municipal waste into gasification. So a lot of those challenges are around the composition and getting a uniform composition of that. So if you are trying to process a broad range composition feedstock, then your operating costs and your capital costs are going to increase significantly. And different countries in different places around the world treat the cost of biomass and municipal waste very differently. So likewise, coal. We've also had some people asking about pet coke. So pet coke's a perfect example. In some countries, pet coke has a value, and so people put a positive value on the cost of the pet coke going into a gasifier. So in other places, they already have too much pet coke, and they actually have a cost in order to dispose of it safely. So that's just one example of the broad range of factors and impacts of feedstock that you have to take into account in these. And it's very difficult to give generic answers.
All right. Dr. Chavan, would you like to add to this? Because, biomass in our country has high moisture as well. So would you like to add on this question?
Yeah. Apart from moisture-related aspects, availability of huge quantity of biomass and its transportation to centralized large capacity gasification plants. It is also a point of the concern because generally gasification plants are installed near the mine mouth where availability of coal is not at all issue. But in case of biomass, transportation from various fields, it may not be economically viable. When we go for distributed utilization, distributed power generation using biomass, it is possible because for agro-processing industries, at least we can go for gasification. for thermal application and distributed power generation. But for methanol or fertilizer, big capacity plants are very much essential to bring down the cost of the product, where transportation and availability is a concern.
All right, we have another question from Roshan. Roshan, go ahead, ask your question.
Thank you. My question is to Mr. Dahl and Mr. Clune. I would like to know from you the global scenario of coal gasification and cost competitiveness, the advent of recent technologies of methane pyrolysis and green hydrogen, which are being pushed globally by all the developing and developed countries.
Who is the question for, Roshan?
My question is to Mr. Dahl and Mr. Clune, both of them.
Okay. The Air Products team. Right, Mr. Dahl, would you answer that?
Could he repeat the question?
All right.
My question is, good morning to you, first of all. My question is that I would like to know the global scenario in terms of coal cost competitiveness and the sustainability of gasification when compared to the recent technologies of methane pyrolysis using the catalyst, direct conversion of methane to hydrogen, and the green hydrogen that we are talking about from the renewable sources through water electrolysis.
I don't think I'm able to help you with this question. Mark, can you do something on this?
There's perhaps a few comments I can make, and thank you very much for the question. So, not really comparing like for like with these. Let me first of all take your comments on green hydrogen. So Air Products is doing a lot of work. So in the area of green hydrogen, it's something we've made some very significant announcements on recently. So, and we believe green hydrogen has a significant role to play in the global economy in the future. Just as we believe coal gasification also has a significant role to play. Green hydrogen takes a certain set of available resources and is one way of converting those resources, monetizing those resources, and the downstream market is typically when you talk about green hydrogen, it's people who want a zero carbon method of hydrogen supply, typically for energy, for fueling of one nature or another. So green hydrogen is not in the near future going to compete with what people call blue hydrogen or grey hydrogen on an economic basis alone. So if you talk about the environmental impacts, then with gasification, yes, there is a large amount of carbon generated from the process. So a gasification process gives you the ability to capture that carbon dioxide in various ways. And there's a number of solutions you can use to minimize that. You also raised a question about how the economics work in comparison with pyrolysis of methane, I believe. Again, I'm not an expert in that area, so I think taking methane and converting that into syngas is an opportunity. If you don't have the methane available, then it's not a solution for you. It may be a solution in other geographies in the world and other players. So each individual company needs to look at what resources, what inputs they have available to them, so what they're trying to achieve, and then we can work with them together with our partners in Haldor Topsoe to see if that becomes an economic solution for that specific set of factors.
All right. Thank you so much, Mark, for answering that question. With that, we've come to the end of this session. We couldn't have Dr. Malhotra join us, but we are very grateful to all of you for joining us and sharing with us your insights on Methanol and how it could work in India. Thank you so much for being with us, and thank you for sparing the time.
Thank you very much, Anisha. Thank you all very much for taking the time to listen to us today.
Thank you.
Thank you.
We are going to take a break right now, and we will reassemble after lunch around 2 p.m. This is a good chance for all of you attending the session to visit the launch, to have a look at the expo as well, and also network with your peers on this platform. Do use this opportunity and come back at 2 p.m. See you there.